Hi, welcome to today's math lesson on distinguishing between proportional and non-proportional relationships given a table. Our do now says a plant in an experiment was 5 centimeters tall at the beginning of the experiment and grew 2 centimeters each day. We have to create a table, equation, and graph that represents the relationship between the total height, y, and the number of days of the experiment, x. And then we have to write whether it's proportional or non-proportional. So starting with the equation, the initial value or the initial height is 5 centimeters tall, so that's going to be our y-intercept. So we have 5, and then because the plant grew, that means that I know that I'm adding height. So I'm adding the 2 centimeters each day, and y represents the total height, so that means that x represents the number of days. And so since it grew 2 centimeters each day, it's going to be 2x is equal to y. So my equation is 5 plus 2x is equal to y. And then in this table right here, I already have my x values filled in, so we have 0 through 5. So for my process, I'm going to be plugging in the x values into this equation. So I have 5 plus 2 times 0, and that's going to be 5. So when x is 0, y is 5. Then when x is 1, I'm doing 5 plus 2 times 1. So 2 times 1 is 2, 2 plus 5 is 7. And then when x is 2, I'm doing 5 plus 2 times 2. 2 times 2 is 4. 4 plus 5 is 9. So as of right now, I have the point 0, 5, 1, 7, 2, 9. When x is 3, I'm multiplying 5, or I'm adding 5 plus 2 times 3. 2 times 3 is 6. 6 plus 5 is 11. Then when x is 4, I'm adding 5 plus 2 times 4. 2 times 4 is 8. 8 plus 5 is 13. And then lastly, when x is 5, I'm doing 5 plus 2 times 5. 2 times 5 is 10. 10 plus 5 is 15. So as of right now, I have all of my coordinates, and I just have to figure out what I should label my x and my y value as in terms of the units. So my x and my y. And my range in x values is from 0 to 5, and let's see how many squares I have. If this is the origin right here, I have 2, 4, 6, 8, 10, 12, 14, 15. So I have 15 squares. So I can have each square represent 1 unit, or I can have each square represent half a unit. So that means 2 squares would represent 1. So I'm going to go with that so my graph isn't squished together. So if this is 0, this would be 1, 2, 3, 4, 5, 6, and then 7. And then for my y-axis, my range in y values are from 5 to 15. So since this is a square, I know that there's probably 15 boxes on the y-axis. So each box or each unit is going to be the value of 1. So if this is 0, this is 1, this would be 2, this would be 4, 6, 8, 10, 12, and then 14. And our last step is to graph the points. So when we have 0, 5, I'm starting at the origin. I'm moving up 5 units. And then we have 1, 7. So starting at the origin, I'm moving over the value of 1, which in this case is 2 boxes. And then I'm moving up 7 units. And then our next point is 2, 9. So starting at the origin, moving over the value of 2, and then moving up to the value of 9. Then we have 3, 11. So starting at the origin, moving over to the right, the value of 3, and moving up the value of 11. So if this is 10, this would be 11. And then for 4, 13, starting at the origin, I'm moving over to the right, the value of 4, and up to the value of 13. So if this was 12, 13. And then our last point is 5, 15. So starting at the origin, moving over to the right, the value of 5, and moving up to the value of 15. And then from here, I'm going to draw a line to connect the dots. And then in terms of answering if this is a proportional or non-proportional equation, well, seeing our relationship, seeing that our equation has a y-intercept is the indicator, or is what lets us know that this is a non-proportional relationship. So I'm just going to write non-pro to represent non-proportional. Today's TEK is 8.5F. Our lesson target is that scholars will distinguish between proportional and non-proportional situations using tables and equations in the form of y is equal to k times x, or y is equal to mx plus b, where b is not equal to 0. Because if b was equal to 0, then it would just be y is equal to k times x. Our DOL is given 4 problems. Scholars will distinguish between proportional and non-proportional situations using tables and equations with 100% accuracy. Some academic vocabulary words to review are the words linear equation, constant of proportionality, slope, proportional relationship, non-proportional relationship, and y-intercepts. So these are the same vocab words that we've been going over the past couple of days for this lesson on non-proportional relationships. For slope, I've been saying that slope and constant of proportionality represent the same thing because it's just the change in y over the change in x. But our constant of proportionality in math is usually represented with the letter K, and our slope is represented with the letter M. So in this case, we can also refer to it as our rise over our run. Our rise is how much we are going up or down, and then our run is how much we're going to the left or to the right. And so to do that, we would have to subtract our y values of 2 points, and then we would subtract our x values of the same 2 points, and that would tell us what our change in y is over our change in x. So this first I do problem says determine whether the table represents a proportional or non-proportional relationship and write a linear equation to represent the relationship. So for proportional linear equations, it has to be in the form of y is equal to k times x. And for non-proportional linear equations, it's always in the form y is equal to mx plus b. So what we're going to do is we're first going to figure out if it's a proportional relationship. So we have k is equal to y over x. And so we're going to choose the different points and see if they're all equivalent to each other. Because if they're all equivalent to each other, if the constants of proportionality are all the same for each of the coordinates, that would mean that this is a proportional relationship. So our y value for our first point is 30. Our x value is 2, so we have 30 over 2. Then for our next point, our y value is 90. Our x value is 8. And then for our last point, our y value is 150. And our x value is 14. So now we have to see if these are all equivalent to each other. So when we divide 30 divided by 2, 90 divided by 8, and 150 divided by 14, we would see that they're not equivalent to each other because 30 divided by 2 is 15, 90 divided by 8 is 11.25, and 150 divided by 14 is 10.71. So we know that it is not a proportional relationship. So we now know that it has to be non-proportional, and now we have to write the equation for it. So up here are the steps to writing non-proportional linear equations. So our first step is to find the slope. And so we're using the equation y2 minus y1 over x2 minus x1. So the first thing I'm going to do is label my points. So I'm just going to say this first x value of 2 is going to be my x1, and then the second x value of 8 is going to be my x2. Then I'm going to say that 30 is going to be my y1. So do you see how x1 and y1 are for the same points? And then 90 is going to be my y2. And then I'm going to subtract. So I have 90 minus 30. I'm going to write that here, 90 minus 30 over 8 minus 2. So 90 minus 30 is 60. 8 minus 2 is 6. And 60 divided by 6 is 10. So I know that my slope, or my change in y over change in x, is going to be 10, or my unit rate of change. And so from here, I'm going to write the y equals mx plus b equation with the slope. So I have y is equal to, instead of m, I'm going to put the 10. So I have y is equal to 10x plus b. Then my last step is to plug in a point to find the y-intercept. So I can choose any of the points. I can choose the points I already used, x1, y1, x2, y2, or I can even choose a point that I haven't used, such as 14 and 150. So I'm just going to choose x1, y1. So our y value is 30. So I have 30 is equal to 10 times our x value is 2 plus b. So now I have 30 is equal to 10 times 2 plus b. So 10 times 2 is 20. And so I have 20 plus b is equal to 30. To figure out what b is, I need to move the 20 to the other side. And to do that, I'm going to do the opposite, or the inverse operation. So the opposite of adding 20 is subtracting 20, and that's what I'm going to do on each side. 20 minus 20 is 0. So we have b is equal to 10. So my equation is going to be y is equal to 10x plus b. Since our y-intercept, or our b value, was positive. So that's why we're adding it. For this next I do problem, I have to determine whether the equation represents a proportional or non-proportional relationship. So I have y is equal to 3x plus 0. So whenever our b value, or our y-intercept, is 0, that would make it a proportional linear equation, since it's in the form y is equal to k times x. So to answer the question, how do I know if the equation represents a linear relationship? Well, the equation represents a linear relationship if it's either in the form of y is equal to k times x, or y is equal to mx plus b. Those are the two forms of linear equations that we're learning about for proportional and non-proportional relationships. And to distinguish between proportional and non-proportional relationships, you can see that our non-proportional relationships have a y-intercept, or a starting value, that is not at 0. So this would be a non-proportional linear equation. There are several you-do problems where you're given a table and you have to determine whether it's proportional or non-proportional, as well as figuring out what the constant of proportionality is, or the rate of change. And then you have the 4-question Google Forms EOL. Thank you so much for following along in today's math lesson, and see you in the next math video.